Hello and a very warm welcome to everyone joining today's Select Science webinar titled Supercharge DNA and RNA Quantification with Fast One-Step Reads on Lunatic. My name's Tom Casburn and I'll be moderating today's session. I'm delighted to be joined by Nellis Dennis, Product Manager at Unchained Labs, who will be sharing his vast experience of DNA and RNA quantification and how the Lunatic can be used to achieve accurate, precise, and high-throughput quantification data, even at low sample volumes. Following the presentation, we will be moving on to our question and answer session. So if you have any questions, please feel free to submit them at any time during the webinar. And you can do this by clicking on the purple tab on the left of your screen and then typing in your question. Without further delay, I'd like to hand over to Nellis for today's presentation.
Thanks, Tom, for the introduction. Hello, everyone. Thank you for joining us today. I'll show you how you can supercharge your DNA and RNA quant with Lunatic. Once upon a time, a very strong lumberjack asked for a job with a timber mill, and he got it. The pay was good, and so were the working conditions. For those reasons, the lumberjack was determined to do his absolute best. His boss gave him an axe, and on the first day, the lumberjack brought down 18 trees. "Congrats," the boss said. "Keep going." Very motivated, the lumberjack tried harder the next day, but he could only bring down 15 trees. The third day, he tried even harder, but he could only bring down 10 trees. Day after day, he was bringing fewer and fewer trees down. "I must be losing my strength," the lumberjack thought. He went to the boss and apologized, saying that he could not understand what was going on. The boss asked, "When was the last time you sharpened your axe?" "Sharpen? I had no time to sharpen my axe. I have been very busy trying to cut down trees." Now, so what's the moral here? We sometimes get so busy and focused on what's in front of us that we don't take time to evaluate the tools we're actually working with, taking care to work with the sharpest axe that can help us do the best job. That is why I want to talk to you about the Lunatic, since it's the sharpest tool for fast, one-step DNA and RNA quant. Our Lunatic is a full-spectrum UV-vis spectrometer, which requires only 2 microliters per sample and no dilution steps, nor standard curves. Lunatic can measure up to 96 samples at a time in just 10 minutes using our plates with 2 microcuvettes, which allow reading higher concentration samples. If you would only work with low concentrations, we have a second plate with 1 microcuvette, and the 96 samples will be read in just 5 minutes. Our plates have a standard SBS footprint, so they're compatible with liquid handling robots. The analysis software is easy to use, and data is easily exported. We'll discuss some of the advanced analytics capabilities a little later in this presentation. Now, how does Lunatic do this? Well, Lunatic is the only system out there that can measure nucleic acids at high throughput and at high concentration. The microfluidic circuit with 2 fixed path lengths, as you can see highlighted here, cover a wide dynamic range of 0.03 to 275 OD. The unique microfluidic circuits molded into our Lunatic plates and chips ensure that there's no cross-contamination or evaporation. Once the sample is loaded, it's pulled into this reservoir area here by capillary action. Fixed cuvettes make for accurate and fast concentrations, since we can always be sure of the path length used in Bayes' laws calculations. It also allows us to correct for stray light and other background. Fixed path lengths mean you know exactly what you're measuring. Let's take a more in-depth look at how it works. Samples are deposited into the input well and drawn into the storage channel by capillary action. A sample can be left in the storage channel for up to 2 hours without detectable evaporation. After the plate is loaded into the instrument, the empty microcuvettes are read. That removes any absorbance contribution from the plastic. And then a pump applies a small vacuum which moves the sample into the microcuvette for reading. High Lunatic plates have 2 microcuvettes in each circuit, with a 0.1 and a 0.7 millimeter pad length. The two different sized microcuvettes make the wide dynamic range from 0.03 to 275 OD possible. The 0.1 millimeter cuvette provides a short enough pad length to enable a high maximum detectable absorbance. How can we prove that our fixed pad lengths are so exact? By using two pad length absorbance standards for microvolume specs, certified by the National Institutes of Standards and Technology, or NIST. Uracil and tryptophan NIST standards are measured for absorbance, and the expected value is compared to the measured value. If they are close, then our fixed pad length can be used for accurate and reproducible measurements. All of the pad lengths calculated, based on the measured absorbance, in 5 instruments run in octuplicate of the uracil and tryptophan standards were within 1.65% of the nominal pad length, and the mean, the x on the graph, and the median, the line on the graph, were within 1.25%. This means that Lunatic generates data you can really trust. Here's a look at linearity, accuracy, and precision. This shows a DNA dilution series of calf-thymus DNA from 25 nanograms per microliter to 1,400 nanograms per microliter. The close agreement between the target concentration and the average measured concentration shows off Lunatic's spot-on accuracy within 2% of the expected value. The low percent coefficient of variation values across the dilution range help show off its amazing precision, typically below 1%. Delivering this dynamic range, linearity, accuracy, and precision is the advantage of using two fixed pad lengths. Groups producing plasmids, for example, typically work with high concentrations. I spoke with a customer recently who was getting variable results due to sample dilutions that were required with their old method. For that group, Lunatic was a great solution because they could read samples without any dilution. The data shown here demonstrates how Lunatic handles high concentration samples without dilution with the same great accuracy and reproducibility. The highest concentration of DNA in this dilution series was 12.8 micrograms per microliter. The R-squared value for the series showcases the high linearity across the huge dynamic range of Lunatic. Just run your samples at the concentration you're already working with. Don't add in extra dilution steps you don't need. Since DNA and RNA samples can be extremely messy, I want to show you on this slide and the next one how Lunatic's Unmixed applications let you see annoying impurities that other UV-Vis systems would mistake as DNA or RNA. Here we're looking at results from a sample of pure calf-thymus DNA in TE buffer. This is a typical result for a clean sample. We can see the expected peak maximum at 260 nanometer. Quality ratios are at the expected values, so 8 to 60, 8 to 80 around 1.8, and 8 to 60, 8 to 30 slightly above 2. Note the accuracy and reproducibility. We're seeing nice, low standard deviations and percent coefficient of variation for these triplicate reads. Now we're looking at the result of a DNA sample that has been contaminated by protein. In both graphs, the blue line is the total measured spectrum. Simple total absorbance data is on the left, and on the right, we're analyzing the sample with our Unmixed algorithm to deconvolute the total signal into the signal from the DNA and the protein and other impurities. By using Unmixed, we know exactly the problem and how to solve it. This sample would have to be repurified before using it in a downstream application. Don't miss contaminants that can screw up your sequencing. Check your preps on Lunatic and know what's in your sample. One of our customers had an issue where they were getting higher DNA concentrations by absorbance measurements compared to when they used a fluorescent dye. To troubleshoot this, they ran lambda DNA through their purification system and compared the sample using Lunatic before and after purification. Concentrations were similar, but the sample had significantly higher turbidity after purification. This is shown on the right. The customer concluded the most likely source was bead carryover from the purification. Now, our Unmixed app successfully deconvoluted the turbidity spectrum. In fact, the Unmixed results were actually closer to their fluorescent dye results and could be done faster and cheaper without additional reagents and dilution steps. Fluorescence protocols are multi-step, require dilutions, take time, use costly reagents, and can introduce pipetting errors which negatively impact results. You will need at least 6 steps to get to your actual results with a lot of sample prep. On Lunatic, you can just load and read, no sample prep at all, and no need to dilute to get into the measurement range. Costly fluorescent dyes are only linear for a short range. At low concentration, Lunatic and picogreen agree, while at higher concentrations, costly fluorescent dyes will saturate. Ditch the time-sucking dye-based wasteful standard curves and the risk of being outside the linear range. Know right away if your samples are good to go with Lunatic. In the experiment shown here, you can see the linearity for samples read using Lunatic across a wide concentration range. You're able to see the saturation effect with picogreen here. This curve was generated using the same samples as for Lunatic, but the samples were diluted to 100-fold. Because of the limited dynamic range with a fluorescent method, a sample might have to be diluted multiple times so that it falls on your standard curve. You will run the samples from different parts of your dilution to make sure at least one of them falls in your measurement range. This is a waste of samples, reagent, and time. On the other hand, Lunatic offers a wide dynamic range with reproducibility and accuracy without the hassle of standard curves and dilutions. And these multi-step procedures have an impact on readout accuracy and precision as well. This experiment was run by one of our high-throughput customers. They measured thousands of genomic DNA samples using either Lunatic or picogreen. Based on those results, the samples were adjusted to 25 nanogram per microliter and then read again. You can see there's a much wider variation in the results with picogreen compared to the samples read on the Lunatic. And in the range where Lunatic and picogreen both work, there's a good correlation between the methods. We're showcasing that here with results from the UK Biobank cohort. This was a massive genotyping project involving about 500,000 participants. Results from almost 500,000 samples show strong correlation in readouts using Lunatic compared to picogreen. Importantly, there was also no difference in the quality of downstream data. Now to go into plasma samples. Plasma samples have the same visual appearance, color and clarity, but have completely different biological components. Lunatic can distinguish between these samples. Take the guesswork out of plasma quality determinations. Lunatic eliminates uncertainty by measuring the full UV spectrum and quantifying the plasma-relevant components, hemoglobin, bilirubin, and protein, along with sample turbidity profiles. Don't lose sleep over instrument-to-instrument or lab-to-lab variation. Lunatic loves repeating itself, so standardizing your methods across all labs is very easy. With boatloads of sample at multiple locations, the last thing you need is to struggle with validating the same workflow over and over again. Here you can see a box and whisker plot with 3 concentrations of DNA. Either run in octuplicate on the same system or run in octuplicate on 8 different Lunatic systems for a total of 64 samples per concentration. On one instrument, we've already discussed the amazing results earlier in this presentation. Here we can see that with 8 completely different Lunatics, there's also nothing to worry about. Having systems in different labs in the same building or even at different sites globally will always provide the same high-quality results. In addition to the capabilities we've discussed so far, Lunatic also meets the needs of labs working in larger scales. For these high-throughput labs, the plates used for Lunatic are SBS standard and so compatible with liquid handling robots. The system can be fully integrated with our API setup, so the robot does all the work for you. from loading the sample to setting up the experiment, to loading the plate in the system and starting the measurement, to exporting the results in your LIMS. On top of that, you can use plate tracking with barcodes, ensuring traceability. And the features don't stop there. We have IQ/OQ procedures available, and for labs doing manufacturing, quality assurance, and quality control, Lunatic now has a performance verification for new instruments. These tests with certified cuvettes meet the United States Pharmacopoeia and European Pharmacopoeia guidelines for UV spectrometers. The tests and all necessary calculations are handled automatically by the software. Finally, Lunatic's software is also 21 CFR Part 11 compliant, with full audit trail and electronic signature capabilities to help you achieve full integrity on your experiments and reports. It's time to supercharge your workflow with Lunatic to get the sharpest tool for the job of nucleic acid quant. Thank you for attending my presentation. I'll take any questions now.
Thank you, Nellis, for that excellent presentation. It's now time for our question and answer session. So if you have any questions for Nellis, please do send them in now. And you can do that using the purple tab on the left of your screen. So we've had a few questions come in already. And the first one here is, how does the Lunatic handle oligonucleotides?
The Lunatic has multiple applications for oligos, so oligos with DNA or with RNA. And then you just need to put in either your molecular weight and molar extinction quotient, so the software can calculate the concentration factor, or just a sequence of your oligo, and then the software will calculate your concentration factor. So it works good with oligos.
Fantastic, thank you very much. Our next question is, what should I use to blank with Lunatic?
That depends a bit on the application you're using. For normal or the general applications, it's rather blanking with your sample buffer. With our unmixed applications, you should use water as blank to not interfere with the fitting.
Okay, thank you very much. Our next question is, does Lunatic have any applications for other biologic samples?
Yes. Nucleic acids is definitely not the only ones. So we have the DNA, RNA, plasma QC apps, but also for protein, for labeled biologic samples, or at any wavelength. Since we have full spectrum, we have an addition where you can make your own application and choose the wavelength of interest. So a very specific need and you need our help, we can definitely do, but a high variety of biologic samples can be measured.
That's excellent. Thank you very much. So we have a question come in here, and that is, how can Lunatic help to measure RNA concentration from lipid nanoparticles?
I would say, in general, with our RNA turbidity, that would work, but then I would rather refer to our new system, the Stunner, that also does DLS, and we have an RNA LNP specific application for that system to really get your total RNA concentration there. So if you're looking into getting your RNA concentration from lipid nanoparticles, I would definitely like to forward you to our Stunner system for that.
Fantastic, thank you. Next we have, when you compared Lunatic to Pico Green measurements, which settings application on the Lunatic did you use?
I don't exactly know for that specific measurement, but I would mainly the general application, so the general 8060 turbidity application for DNA.
Great, thank you. Our next question is, using a liquid handler, would we need to aliquot the same volume of liquid to the plate?
Our Lunatic consumable requires 2 microliter. There can be about, as a tops, 20% variability on that. But so everything between around that 2 microliter with a tops of 20% variability is needed.
Excellent, thank you. Our next question is, do I always need to run a full plate?
No, that's definitely not needed. You can mark what you used and just run, for example, 16 samples instead of 96, and then use the rest of your plate for your next measurement. So we don't need to always run 96 samples.
Excellent, thank you. Our next question that we've had is, what is the lowest concentration of DNA and RNA that can be measured?
Our limit of detection for double-stranded DNA is 1.5 nanograms per microliter. If I'm not mistaken, for RNA, that would make it 1.2. So in general, it's our absorbance limit is 0.03 OD, and depending on what exactly it is, the concentration factor is implied. So for DNA, 1.5. For RNA, I think 1.2 by heart.
Excellent, thank you. Our next question is, why are DNA concentration measurements with Lunatic different from the nanodrop when there's the same probe? So nanodrop by default would do a single point correction, and so you decide on which wavelength you want to correct your spectrum with. Of course, turbidity is not nicely linear or equal overall your complete spectrum, and so with a turbidity correction, as we in general would use, you actually correct at the wavelength of interest for that way, and you don't do a single point correction. So that can introduce small differences, but overall, a turbidity correction will be more accurate. Excellent, thank you. So a question coming in is, can you please elaborate on how the Lunatic would fit into automated workflows?
I would say that's very dependent on exactly what you want to do. You can put it basically everywhere in your automation. If you have a sample that has an unknown concentration and you want to normalize it at the end, you can run it on the Lunatic, get your output automatically going back into your automation setup, so you know how much volume you need to dilute and things like that. So I would say there's a high amount of possibilities, and we can definitely help you look into where it would fit in your specific system.
Fantastic. Okay, so we have a double question coming up, and the first is the reproducibility also that excellent for long RNA, and also all common 3-5- internal modifications?
The reproducibility is overall how homogeneous the sample is. It's on the absorbance, so I would say yes, but I can't say it with 100% certainty on those specific samples. But yeah, I would be quite confident that it will be as good.
Fantastic. Just reading the second question here. Is it only feasible for less than 96 samples at once, or is the most sustainable approach to use the full 96 well plate?
The instrument will work the same depending on how much you're measuring. So if you do one sample or 96, or even you can set up a multiplate experiment up to 10 plates, so 906 samples in one measurement, and the instrument will work as good with each amount of samples you chose.
Excellent. Thank you for clearing that up. Our next question is, can I run experiments with different buffers on one plate and still blank?
Yes. So in the software, there's a lot of functionality, and one of those is putting your 96 well plate in different sample groups. And so for each sample group, you can specify which samples are in that group and which blank that needs to be applied to that sample group. And so yes, there's no problem on doing multiple samples with different buffers and still correct with the correct blank.
Brilliant, thank you. So we've got time just for a couple more questions. So our next one is, how are other impurities separated from the DNA or RNA measurement?
So that's for our Unmixed applications. And so basically you have your raw spectrum that is measured, and then from the other impurities that are specified, and of course our DNA or RNA, those spectra are known. And so our algorithm will find the best fit for those things combined. So that is why it's a select amount of impurities, and it's not just any random thing that will be fitted there. It is a known impurity for us.
Fantastic, thank you. So we've got time for just one more question, and that is, can the system be connected to LIMS?
Yes. So our outputs can either be from in your automation setup, or when you use it standalone, you can get multiple output files, CSV, the most common used in automation, but just Excel or PDF or whatever you would like from the standalone, and that can be preset in which columns you want, in which order, and then go directly into your LIMS, so you don't need to worry about that or data issues.
Fantastic, thank you, Nellis. So that's all we have time for today. So thank you again for your excellent presentation and your discussion. And thank you to everyone joining us online and for sending in your questions. If we didn't have time to answer your questions, we will follow these up after today's event. So if you do have any other questions, please feel free to submit them now at the side of the screen, or email me at editor@selectscience.net, and I'll follow up on these for Nellis. Remember, you can download a certificate of attendance in the Related Resources tab, indicated by the file icon on the left of your screen. As always, if you'd like to listen again to today's webinar or invite a friend to listen, it'll be available to watch on demand in a few days' time. So thank you ever so much, Nellis, for that presentation. And goodbye, and thank you once again for joining us.